Hey guys, please welcome back in my today's session. And before starting our today's session, previously what we have did, I'm just giving just a little bit highlights. That we last time we have seen that the expansion of for the sin and theta and cos and theta as well as tan and theta. And before that we have just completed the roots of complex variable. And now in this session I'm going to conduct one more important topic, and again it is very much easy, we can say that. So we are going to conduct that only, and this is same like expansion only as we did in our previous session. This one is again expansions of for the same functions, but it will be in the form of raised to n form. Okay, so start with the part 1 only for the complex variable. Here you can see the method of expansion of sin raised to n theta and for cos n theta in terms of sin n theta and in cos n theta. Okay. Now here what will be given into the equations? Here it will be the question like sin raised to 7 n theta yani ki 7 theta, or else it will be cos raised to 8 theta. Okay, it means the equation will be in the form of power, in the terms of power, yani ki either it will be 2 or 3 or 5 or 11 etc. we can say that. Okay, and its answer will be in the form of sin n theta and cos n theta, yani ki this, I'm highlighting this term guys. And if I talk about our previous session, the question or our method was like, the question was in the form of sin n theta and cos n theta, and we were converting into the sin theta and cos theta. And here the question will be like, again repeating, the question will be like in the form of power terms, right? यानी कि पावर में कुछ ना कुछ दिया होगा आपको, like 7, 3, 8, 9, 12, 13 etc. And this all the components you have to convert into the n theta form, yani ki it will be in form of either sin n theta or it will be of cos n theta. So hope you all understood guys. And for that, here there is given some of the theory of this expansion, and this one is very much important guys, because without understanding this theory you can't able to solve the examples. Okay, so let I'm applying first x equals to cos theta plus I sin theta, and for this function x I'm finding one more component 1 upon x. Okay, and 1 upon x is nothing but it's just like we are applying De Moivre's theorem, because if you will shift x into the numerator then it will be x raised to -1. We can say like this, and I'm also writing here it will be the x raised to -1, and here applying this De Moivre's theorem by applying -1, then it will be cos theta minus I sin theta. Okay, so now I'm just applying, I'm just taking a addition of x and x1 plus x. I'm just highlighting guys, 1 minute. Okay, x plus 1 upon x, and also applying for x minus 1 upon x. Okay, now this one why we are doing, because now adding these both the terms you will get answer as in terms of cos function. Okay, and by subtracting these both the components you will get answer in the sense in the form of sine. So the equation, if the equation will be in the form of cos, then first of all you have to find x plus 1 upon x. Again repeating guys, if the equation will be in the form of cos theta, cos function, then you have to first take addition, or else you have to find a term of x plus 1 upon x. And now next, if the question will be asked in the form of sin theta, okay, अगर आपको sin में कुछ दिया है equation में, then you have to take a subtraction of this both the components. So it will be x minus 1 upon x. Okay. So hope you all got it, guys. This one is very much important because as we will do in our examples. Okay. Now again, I'm just dividing. I'm just writing one more simplification. Okay. So in place of x, now I'm writing x raised to n power. So that will be, of course, cos theta plus I sin theta whole raised to n power. Here you can see that. Okay, and here by applying the Mobius theorem, you can get that cos sin theta plus I sin n theta. And same I am finding like 1 upon x, then here it will be, we will find 1 upon x raised to n form. So of course we will be like cos n theta minus I sin n theta. Okay. So hence again we will take addition of these both and we will do one subtraction for these both the components. So by adding these both the terms we will get answer in terms of cos, and by subtracting these both the components we will get the answer in terms of sine function. So from this all the theory, which part is important? That if the question will be given in the terms of cos, then you have to find these both the numbers as I am highlighting, that x plus 1 upon x and x raised to n plus x raised 1 upon x raised to n, and this is for the cos. And if the question will be in the terms of sin theta, then you have to find this one term, or else we can say that this one term. Okay, and this is for the sine. So I hope understood, guys, that you understood this theory very well. And now I'm starting the examples, and here you can see that first illustration is given like expand cos raised to 8 theta in terms of cosine of multiples of theta. So cosine, it is nothing but it's just a cos theta, cos n theta. Okay. So first of all, based on the theory, your first step will be in terms of x only, yani ki x equals to c theta, and c theta yani ki cos theta plus I sin theta. Okay. I mean this one. Okay. Now for the next, you can see the question again, guys. Here it's given for the cos. So of course the answer will be in terms of this. Okay. So for the cos, as we have discussed in theory, you have to find two components like x plus 1 upon x and x raised to n plus 1 upon x raised to n. Okay. So for x plus 1 upon x, it will be you have to just take an addition. So by taking addition, it will be 2 cos theta, and for the x raised to n power plus 1 upon x raised to n, it will be 2 cos n theta. Now see, here we don't have for the nth term, right? Here it will be for the 8th term, yani ki in place of n we will put 8. So the answer will be x raised to 8 plus 1 upon x raised to 8 equals to 2 cos, here just 1 minute, I am just writing this term. So this one will be 2 cos, okay, 2 cos n, in place of n you will write here 8 theta. Okay, so based on n the theta will be changed. Okay guys, so okay, now this one x plus 1 upon x is nothing but 2 cos theta whole raised to the same power, yani ki I am applying 8 on both the sides, right? So this one cos theta whole raised to 8 power, putting these two in the downstairs, so it will be 1 upon 2 raised to 8. and applying the values of cos theta. So we can apply cos theta equals to this one, yani I'm just highlighting, yani ki this. Okay, so just I'm doing this one whole raised to 8 power, yani ki 2 we can apply in the downstairs, and 1 plus x, 1 x plus 1 upon x whole raised to 8. Okay guys, now next one, 1 upon 2 raised to 8, I'm just keeping as it is, and then after 1 x plus 1 upon x whole raised to 8, yani ki we have to apply binomial expansion as we have discussed in our previous method. Okay, so first of all this one is a and this one will be b. So x raised to 8 yani ki a raised to m plus nc1, here it will be nc0, then after nc1 nc2 up to the ncn. Okay, so nc1 nc2 yani ki in place of n here it will be 8, so nc0 that is 1, nc1 nc2 nc3 nc4 5 6 7 and 8. Now for the next, the second term yani ki x, the power of x will be increase, so sorry decrease, and the next one, just a second guys, the second term of x yani ki the second term yani ki b, first term is your a, I'm just highlighting guys so that you can get that this one is your a and this one is your b. So this one is first function, this one will be your second function. So I hope this one you understood, nc1 2 up to the 8cn. Now then after, the power of x yani ki the first term of x will be decreased, and the power of b yani ki the power of 1 upon x, that will be increased one by one. So first I'm talking about the first one term, that is of x term, so that will be decreased yani ki it raised to x raised to 8, then after x raised to 7, x raised to 6 5 4 3 2 1 and 0 power. Now next, the second term yani ki the power of 1 upon x will be increased, so that will be 1 upon x whole raised to 0, then after 1 2 3 4 5 up to the 8 1. So this is actual known as binomial expansion. Now I'm just to gathering the terms. So first of all I'm writing for the x raised to 8 power, x raised to 8 here, and also we are getting here because 8c1 will be 1, x raised to 0 also 1, so the remaining term will be 1 upon x raised to 8. So I am just making a pair of a similar power. Okay, so x raised to 8 plus 1 upon x raised to 8. Now secondly, if we talk about uh, after giving the simplification, I'm writing this term, but the one step after this one I have cancelled, I've just skipped out, but you can just write if you can't do orally, then okay. Now this x and this one will be removed, so it will be x raised to 6 power, and similar I'm finding a same term for this, so this one will be the pair of this and the second last term yani ki this one, and we can made a pair of x raised to 6 plus 1 upon 6. Now as well as we will do for the next, and here you can see that x raised to 6 and here it's given x square, so cancelling this you will get x raised to 4, and for the similar term you can see the third last term of the equation, that is from this one. Okay, yani ki this both the terms, so that will be here x raised to 4 plus 1 upon x raised to 4, and at the last we will do the remaining x raised to 5, and here it is x cube, so it will be x square term, that is this one, and at the last the one term will be remain, and that is actually your this one, 4 x raised to 4 and 1 upon x raised to 5. Okay guys, so I've just give the simplification, and at the last the pair which we have made, in place of that you can apply this formula. So you can use this formula as an x raised to n plus 1 upon x raised to n power. So I'm applying this formula. Okay, now this is for the 8 power, so that will be 2 cos 8 theta. This one is for 6 power, so it will be 2 cos 6 theta. Similar for the this one, so it will be 2 cos 4 theta, and then after 2 cos 2 theta. And this one will be as it is, because x4 x4 will be cancelled, and 84, that will be 70. So I have just written here 70. Okay, so I'm just giving the simplification, and as you can say that 2 is common for all the components, so I'm just cancelling out, so it will be 1 upon 2 raised to 7. So this one will be your final answer. Now see the second term, second example. You can observe that here it's given the expand sine whole raised to 7 theta in terms of sine yani ki sine and theta of the multiples of theta. So as we have discussed in the theory, there will be two kind of equations only. One will be for the cos and the another will be for the sine function. So first example we did regards based on the cos theta, and the second examples we are doing for the sine theta. And as per theory you can see that there is one more formula for the sine theta. So specifically to solve the sine functions you have to apply that formula only. Okay, and you can see there for the sine we have to apply its negative components, yani ki we have to apply its subtraction. So x minus 1 upon x and x raised to n minus 1 upon x raised to n. See guys, here I have highlighted, and that will be this one will be 2i sin theta, and for this one 2i sin and theta. This one we have already proved in the theory, and now with the same procedure and only here we need whole raised to 7 power. So in this term, yani I'm just circling, yani ki this one, as I'm doing the circle in the equation. So in this equation you have to apply 7th power on both the sides. Okay, and you just make a subject of this one, and then after this one you have to solve it with binomial expansion, and you will get the final answer. So this one you have to do with your own self guys, and as we have said, I would already said to all of you that if you have any kind of queries then you can contact me anytime. Now next, here it's given three more examples, and this one you have to do practice in your assignment book, and if you have any doubt then you can ask me anytime. So this method has been completed over here, and in our next session we will do next method. Thank you guys.